Hi, I'm Phil and I'm Director of the Curtin Space Science and Technology Centre.
Hi, I'm Renae and I'm the Research Ambassador.
We are the largest planetary science research centre in the Southern Hemisphere.
And we represent Australia's planetary research community to NASA.
We are working with research agencies and space agencies all over the world. We're working with NASA to send an Australian spacecraft to the moon. We're working with the European Space Agency, who are going to give us free mission control for that mission, and a whole bunch of other missions as well.
Our work reaches around the world, but as well as that, people around the world come to study and research with the Space Science and Technology Centre at Curtin University. We have a few stories to share with you today, a few things that we hope you can learn and hope to inspire you with the world of blue sky planetary research here in Australia.
We're excited about our next adventure, which is to expand what we do in STEM and bring in more Western Australian students so that they can learn planetary science and also spacecraft engineering, which is where we're going next.
It's exciting times for undergraduates. It's also the home of top planetary researchers around the world, represented on over a dozen international space missions. 6 of them active at the moment, and we're going to give you a little insight to some of them right now.
There is actually a mission called InSight. It's a NASA mission that's currently operating on Mars. 2 years ago, NASA sent the probe to Mars to survey its interior. And I've been very fortunate to be part of that mission as a collaborator. And in fact, not only me, but I lead a group of young scientists here at Curtin, and we're all involved with the NASA InSight mission. Our job is to look after for Marsquakes, especially the ones that could have been caused by impacts from space, so rocks from space hitting Mars, and then we can actually hear them here through Marsquakes and InSight on Mars.
We're involved in a whole bunch of space missions, and it's tremendously exciting to actually interact with agencies all over the world as that data is coming back. And as part of a mission science team, we're amongst the first people in the world to actually see what a space mission, what a space probe is sending back. One of my first ones was the Stardust mission, which recovered data and particles from a comet. It was tremendously exciting. We were going to analyze those materials in the lab when the spacecraft brought them back. I always had it in my head that that they turn up padlocked to some NASA security guard. In the end, they were just in a FedEx parcel, which wasn't nearly as exciting, but it was still tremendous to actually get bits of a comet. But we do a load of space missions, and we're going to tell you a little bit more about those right now. We do, in addition to what CAT does with InSight and several other missions like that, we're really known for our work on sample return missions like Stardust. And there's a couple more of those that are active right now. We've got collaborators with JAXA, which is a Japanese space agency, on the Hayabusa mission. And that's bringing asteroid samples back from an asteroid called Ryugu. It's going to be landing in December. We're also part of the observation team for the re-entry. And there's a NASA mission called OSIRIS-REx. We're going to be analyzing material from that. And we're currently working with NASA on how all the sample analysis team all over the world, it's like 100 different scientists, are going to work together analyzing that material. Space missions, on the one hand, are all about the blue sky research, but on the other hand, they deliver fundamental benefits to our economies and space industries. Teams of researchers, the engineers that put together those missions, are always pushing the boundaries in terms of what spacecraft can do. It's just a great way of generating innovation. And that drives space industries all over the world. That drives everything the US done and has succeeded in doing over the last decades. We're trying to do that as well with the Curtin Space Science and Technology Centre.
I have the great opportunity to work here at Curtin as the program manager of the BINAR Space program.
And I'm one of the engineers that works for Ben in the BINAR Space program. I look at building one of these awesome CubeSats.
The BINAR Space program is named for the Noongar word for fireball, which ties us back to our heritage in the Desert Fireball Network. We've developed a lot of experience in building remote systems, and that naturally flowed into building a remote system in space, which is a spacecraft.
So this spacecraft here, just a bit of a skeleton of one. Typically we buy these in sets of racks off the shelf from international partners. But what we've done is we've combined it all into one smaller payload, which we're going to use to integrate some of our payloads for our PhD and also for future space missions going into the future.
And by designing that all at Curtin, we have the opportunity to produce as many as we want to, which means we can explore a lot of opportunities for missions for Western Australia to inspire high schoolers, university students, do science and research, and also take on technology challenges in space. In the BINAR Space Program, we have a team of engineers and scientists who are all from Western Australia, building Western Australian hardware for Western Australian missions. And that's really exciting. I did my degree here at Curtin, and I'm now working on a space program which will send spacecraft into space in the near future.
Yeah, so that's what we're all working hard towards now, is this spacecraft will first be launched next year in March. So we're really excited for that and can't wait to get it up there in space and eventually out and testing working product.
We've also got a lot of contacts through the Space Science and Technology Centre with a lot of international partners. So we get to engage in global space activity, which is really exciting for people here in Western Australia to have that opportunity right here in Perth. Over the next few years, we're going to have so many opportunities to launch. We're going to be growing our team of students and engineers here at Curtin, and we're going to continually iterate towards a more capable platform. So we're going to take on more challenging missions. A lot of what we do comes from our heritage in the Fireball network, which is the remote observatories out in the desert. And I got to be part of building those. And there's a lot of similarities with spacecraft to those remote systems. We developed a lot of the experience we need because we were building solar-powered, disconnected systems that had to operate on their own out in the desert. And I like to think that a launch is a lot like a PhD student driving a Ford drive across the bumpy desert. It shakes your equipment, and you have to make sure you can survive that harsh environment.
So we take a lot of the learnings from the DFN and what Ben's done with their cameras and taking them out into the harsh environment, and we apply the same tests that they do to their cameras and to all of our systems. So we do like vibration testing, we do serious power testing to make sure our batteries are going to be safe in space, as well as vacuum and thermal vacuum testing to make sure that our spacecraft can survive the space environment and make its way up there safely.
Hi, I'm Ellie and I'm the project manager of the Desert Fireball Network. So we basically have cameras all the way across Australia in these arid desert regions taking pictures of really, really bright shooting stars that we call fireballs. And the idea is that from different positions, we can actually what we call triangulate. So we can figure out where that rock is coming through our atmosphere and figure out not only where it comes from in outer space, but where it might have dropped a meteorite on the ground. So Lucy here has a really exciting rock to show us.
So my name is Lucy. I'm fortunate to be able to work on these physical rocks that have come from lots of different places in our solar system. So this particular rock we only recovered recently. So this is called Madura Cave. And this rock is really cool because it actually seems to have spent most of its orbit somewhere between the sun and the Earth. So it has an ATEM type orbit, which is really quite unusual. Now, the power of looking at these kind of samples really comes from being able to have a look at the rock. So we CT scan the rock first. We want to look at exactly what's inside the rock, which is very cool. And then we'll break a little bit off so we can have a closer look. And then we start to do lots of really, really cool science where we zoom in further and further and further until we can look at even the atomic scale parts of this rock. And the reason we do that is because these rocks have come from all over our solar system, and we are essentially building a geological map of our solar system. And the power of being able to understand the orbit and therefore where this rock might have come from enables us to do that.
We've spread these cameras across the world. We're now part of this global Fireball Observatory, and we're looking at the skies all across the globe, looking for these really unique specimens. And these are really, really special because there's probably around 60,000 meteorites in collections around the world that can give us this valuable information. But without that spatial context, we lose so much. And there's less than 40 of these rocks ever recovered with orbits. Basically having that technology that we are providing here from Curtin to be able to observe these fireballs with enough accuracy to figure out where these rocks come from in the solar system.
So not only do we send our technology all around the world and is it used globally, but we also send little pieces of the space rocks that we find in Australia with our Desert Fireball network around the globe as well. We rely on input and assistance from our collaborators all over the world, and they're able to do some really cool analyses for us. We are world leaders in this area, and people really look to us for our expertise in this area. And so the spotlight really is on the SSTC at Curtin University.
My name is Andrea and I come from Belgrade, Serbia. Here in SSTC I'm doing PhD about impacts that are currently happening on Mars, and I'm using numerical modeling to do that. Back in Belgrade I was doing geology, structural geology and tectonics, but I was highly involved with Petnica Science Center that had a group for meteor observations. And so I thought that SSTC is a perfect place to combine my passion for meteor observations and my background in geology.
Hi, my name is Patrick. I am from Pittsburgh, Pennsylvania in the United States, and I'm a PhD candidate in SSTC studying orbital history of impact debris hitting Australia every year. And I came to the SSTC after working at NASA Glenn in Cleveland and heard about the great people here and all the different work they do. And it was a perfect opportunity given my skill set and the research I wanted to do. So coming to Australia and to Curtin was a perfect opportunity for me to work with the Desert Fireball Network, which is the largest network of its kind in the world, studying impact debris all over Australia.
But in general, SSTC gives us opportunity to do all the planetary stuff that is very unique in this southern hemisphere. So it makes it the largest planetary group in the southern hemisphere.
I'm Nick. I coordinate lots of the fieldwork that we do at Curtin University as part of degree programs. We emphasize fieldwork quite strongly at Curtin. It's a really good opportunity to learn so much about how the Earth works and how planetary science is moving forward. We are lucky enough to have some great fieldwork in Western Australia, and all our undergraduate students have opportunities to become part of some of the scientific discoveries that we're making quite regularly from Western Australia, and from samples that come to us from other means as well. For example, this is a sample from the moon that was collected by the Apollo astronauts back in the 70s from NASA, and other places too, Gretchen.
Yeah, we get materials from asteroids, but we also get them from places like Mars, which you can see a picture of behind me.
Yeah, but not only that, Western Australia particularly is really unique in all of the places that we can go to in the field. And a lot of our undergraduate students are involved in discoveries through fieldwork in Western Australia, and also our PhD students and postgraduate students as well. It's a really good opportunity to come and be part of planetary sciences at Curtin University.
And we are also very excited to be able to say that we are now able to teach planetary science using the expertise of our researchers and applying or adding that to our geology degree, which is a fantastic addition. And we're hoping and developing some postgraduate courses as well. And in a couple of years or next year, we're going to have an engineering course that's around planetary science and how to build instrumentation that will fly to space.
SSTC is a home of a range of researchers and scientists, from geologists, geophysicists, geochemists, to engineers working with mechatronics, data analysis, and so forth. And together, we're developing different research methods and doing groundbreaking research in the domain of space and planetary science. But moreover, and more importantly, together we are building a research base and we're thinking about new scientific method. And more importantly, we're developing critical thinking. And those are some key elements for anybody working in STEM and other fields in the future to be able to apply whatever they've learned at school.
So what's really exciting is that Australia has a space agency now, and what we want to do is we want to build up that space industry. SSTC is the place to allow you to learn how to use those skills that'll make you ready to work in the space industry. You'll be able to apply new knowledge of exploration of the solar system. You'll be able to work with engineers on how to build satellites, how to make things space ready. But all of these things are actually applicable back to industry here for the Earth as well. So it's a really nice mix, and we can translate between the two areas. So for instance, some of the work we've been doing is using machine learning to intelligently process millions of images of other planets. But we've been able to take that information, and we now can look at images of the Earth using some similar algorithms. It's very exciting work.
One of the really unique things about working in space science and technology at Curtin University is that the work and research can be applied in lots of different ways. Sure, we're uncovering the origins and evolution of the solar system with our global partners through blue sky research. But what we can do is translate that into real world benefits for ground-based results here in Australia. That's led to some really great collaborations with our industry partners. And one that we are really proud of being a foundation partner in is with the Australian Remote Operations for Space and Earth, recently formed here in Western Australia. An amazing thing here in Western Australia and Australia is our unique capability of remote asset management. Basically, we can run really big, complex things using technology and teams in far-off remote places. Funnily enough, as we go and extend our human presence in the solar system, looking at Mars, from the moon to Mars with the NASA Artemis missions, we're going to need some of that flavour in space. And in fact, that's what NASA is looking to Australia for. So with the amazing techniques between lots of terrestrial sectors, from mining to oil and gas to transport and to health and emergency services, we're able to take that incredible ability to manage things remotely and be able to apply that to managing things in space. This is going to enable Australia a foothold in the international community as we as a species go and explore our solar system.
So it's great to work with those industry partners as part of the ROSE. We also have a long-running partnership with Lockheed Martin, and this is an interesting one because it came directly out of our work on the Desert Fireball network. It turns out that if you've got a big network of little observatories out in the middle of nowhere and you're trying to triangulate meteorites coming through the atmosphere, that actually is a really good way also of tracking satellites. We didn't know that at the beginning. We couldn't have dreamed that it would work for that, but it actually turns out it works really, really well. So our observatories, with a little bit of an upgrade, what we can do is work out the position of spacecraft in orbit to within just a few hundred meters. We can get those positions almost as accurately as if we got a $10 million telescope, but using much more simple components and much more cheaply. We see a really big area, so we can do kind of wide angle observations, but get really nice precision on orbits, which is something that's really hard to do using other techniques. So we've got an example there of a technology that was actually built to work out things about the origins of the solar system that we've been able to translate into delivering data that Australia needs when we want to track satellites in orbit. And that's become a really big priority for our country. Here at SSTC, we do a whole range of things. We study the origins of the solar system, we analyze meteorites, we track them from out in space to the surface of the Earth, we go out in the bush to find them, we build small spacecraft, we work with Australian industry and WA industry to bring our knowledge there into solutions for Australians. But at the end of the day, everything we do in the end is paid for by Australian taxpayers. And it's a real pleasure for us to bring the excitement of what we do. It's a duty to bring the excitement of what we do and show the people who are paying for it why we do it, why it's exciting, why it's worth doing.
What's really special about SSTC and the people that work with us is that STEM engagement and thinking about the world in which we operate in and the communities of which we're embedded in, it's not just a nice to have, it's a critical component of conducting all of this work. And it is our responsibility to bring it to the wider public. And so we work really closely with them. We work with the public in engagement programs and schools. We've won awards with our, multiple awards with our citizen science programs, Fireballs in the Sky. And we see time and time again that our researchers and our staff being able to think about the world in which they conduct their research in. And that ultimately is a really important thing for Western Australia to understand, to have that ownership, and to sort of peek in behind the curtains of research as we really do understand a little bit more about the world and our solar system around us.
So one of the things we want to do next with the BNAR program that we've already started, that you've heard about already, is bring that directly to WA citizens and WA students. We're going to be actually sending up, we're going to have 5 tests of that system next year. And a thing that we want to do is actually bring in, we're talking to the state government right now about this, is to actually enable high school students to put experiments on our spacecraft. So that's a priority for us, so that WA students from high school, if they're interested in engineering on up, can get an opportunity to actually see their hardware or software that they make fly in space. I think that'd be awesome.
Providing real-world teeth-cutting examples and experiences for the generation of now, as well as the next generation, for people wanting to go into space as a career. That's what we're about at SSTC, about integrating all of that incredible research that we do, that world-class innovation, and bringing it right home here to WA to ensure that our state has a place in space.